Yes, now we are going to have a look at semantic and communication, TI portal and communication. So what we're going to look at is communication with an HMI panel. We are not going to do any actual communication, but how that's being configured. An HMI panel, and then we're going to look at communication with something called remote IO. So here is a project again. It's a CPU inserted here. You can expand that one. There are several ways. If you're going to communicate, we need more devices. There's only one device, that's a CPU, with some IO cards in it too. That's something I prepared. The easiest way here to illustrate communication is to open device view. We are going to go to network view, but I've prepared the interfaces here, or the IP addresses for the interfaces. I've just selected a private address and one subnet here, and the other interface has another subnet, and this one also has configured a router. A router normally has the same. It doesn't have to have it, but normally it's configured with the same network address, and it's device number 1 on the network. That's kind of a standard way to set the IP addresses for a router. Okay, so that has been configured, and we have only one unit here. But if you go to network view, I can make this one a little smaller and go to hardware catalog. Then we have quite a bit in the hardware catalog. We have HMI, and that's what we are going to look at. And then we are going to insert something called remote IO, or distributed IO, that they call it here. But if we start with the HMI panel, what we are going to do is to insert them and connect these two networks. And here it's more or less drag and drop. We select our basic panel. We can use this with the 12-inch display, and this one, the reason I use this is we have a license for this display, and then we just drag it into this network view that we have here. Still, they are not connected. So now I got my new display here in the properties windows in network view. I can give it a new name, maybe LOP. Let's use what you use this display for, LOP being short for local operating panel. The first thing we have to do with this one here, it depends upon the unit that I enter here, so I used to use an HMI display as an example. So I have to connect it to a network. We could have put in a network, but the easiest way is just to drag between the two devices, and then I get a network, and it changes to the network down here, the network view. So what I'm going to write in here, HMI, so we can see it as a network. And for a component like an HMI, it needs to use a type of connection, how to communicate, or what kind of, so to speak, the protocol, how to talk to, or how the PLC and the HMI panel, how they are going to talk, what language they are going to use. And the connection we are going to use here is an HMI connection. It's in the name. It's a connection that connects to the HMI. What we do here is we say, okay, physically you are connected like this, and now we need a connection between these. And again, I select this connection, and it's just to drag into the HMI, and then I get an HMI connection, and the property changes down here and say who are connected here. And this connection I can call PLC01, or I could use and say that the connection is HMI to PLC1. That's the connection I have here. So now the HMI panel can communicate with PLC1. There are 2 steps. So I run those 2 steps. There's nothing more to do here, because let's say the communication software is built into the firmware in the HMI panel and the CPU here that I connected with the PLC1. So that was HMI. So the next communication is that I want to establish 2 PLCs, or have 2 PLCs and have those communicate. So then I need another PLC. I could do it here, select controllers, but what I'm going to do now is that I'm just going to minimize that one. Control C, Control V, just make a copy. Because my new PLC is fairly, let's say it's identical to the first one I have the same amount of IO. I can just put it up here, or we could also, if you look down here, there are space down here to place. Usually or often you could do like this and say, okay, the HMI is the top level and my PLCs are a little below here. So now what I can do, I can repeat what I did with PLC 1, but here they have, oh, we could go to the device view for PLC 1, just double click it, and this one has IP addresses, and I make a copy. So if I just select network view and I double click here on the PLC 2, these networks, they have addresses identical. So what I'm going to do, I'm just going to exchange this one using a 1. That was interface 2, and it's the same. They are on different subnets, so I can use the same IP address for the device. So now they have unique addresses. I could also check what kind of IP address did my panel get. Oh, that got 2. I've used on this network, I have a default gateway which uses address 1, but that's okay. We can say, okay, the panels, they start off of 10. So this is my first panel, so I just call it 11. I'm not going to insert more than 1, but it's the same procedure. They can use the same network, connect here, and also they need a connection. These 2 PLCs, hit it here, and we could call that HMI I-PLC02. Let's just have names. So then it is. Now I have the PLCs, and they are now connected to this HMI bus. If I look at the network, so maybe I shouldn't have called it HMI network, because what I want to do is to have these to communicate to. Now they are connected to HMI network that I made, but still I have to tell them what kind of language are you going to use when you talk to each other, and that's again a connection. And that's not an HMI connection, because these are PLCs, and normally you use something called S7 connection. There are more connections in here, but having PLCs talk to each other, it's S7 connection, or that's one of the types you could use. And again, as with HMI panel, I'm going to drag and try to hit. I think I'm going to, that's okay. That was S7 connection 1, and that's PLC01 dash PLC02. Oh, we have to try to hit 2. PLC2. And here, save. And once in a while, it's kind of nice and to compile. There might be errors here. I think it should be error-free the way I'm walking through this, but compile here, then it compiles the hardware to the setup and checks that for consistency. Yes. And here too, I have the units and well, the units I've inserted in here. So the thing is, this S7 protocol doesn't mean that these two devices here, PLC1 and PLC, they can talk. To make these talk to each other, we have to make a little program. I'm not going to make the program, I'm just going to show what kind of built-in functions and function blocks. Basically, it's a function block that you could use to communicate between these, so establish communication. And that's the reason why I had the CPU, because here under programs we have to go, I have a program, and that's, I'm just going to open this here. There is a small program in here, I'm not doing much. I'm just going to make an enter here. Now over here it changed from devices that I could input when it was in network view to instructions, and then I had to look, is there some communication instruction here? Doesn't look like up here. Oh, down here it says communication. Select communication. I have to select it on the, okay, I'm able to select, I'm going to open this a little, I'll make it a little larger. And what we are looking at here is S7 communication. There are function blocks. We're not going to go into this, how to use it, but I'm just going to drag one. What you do here is you select one, and then you drag it into your program. I'm going to make a little more space there, and put this function says, okay, now I'm in this PLC1, and put this as take information and in PLC1 and put it to PLC2, given that that's the communication or network or the PLC I'm talking to. I'm just going to drag it in. This is unstructured text. It needs a data block or what an instance data block to work on, where this function block stores its data, and IDB PLC, normally here PLC02, and just communication or data interchange or whatever, like that. Now I'm just going to leave it like this, because here is, you have to program this, and you have to find this this information, so connection resources and how to communicate, and the REQ requests. If that changes from 0 to 1, it just transfer the data. So this is more complicated, so there is programming involved. I'm just going to delete this one and keep it. So okay, so there is programming involved if you want to communicate between the PLCs. Let's see, if I move over here a little. Down here I have I open the program, and here I can go back and just select my devices and network view. So what I want to do last now is to use some IO. If I double click on this CPU, there are IO modules in here, And also if I go back here and say and select 2, also have IO modules in here. Because it's a copy, so it should be identical. But for PLC2, I'm just going to delete this, or I could keep it. But what I want to do is I want to move this IO into another cabinet and use a network to communicate to the IO. Let the CPU communicate with the IO in our cabinet. So if I go back to network view, that's called here distributed IO, which we call it usually remote. It's somewhere else, remotely installed. So what I'm going to use, I'm just going to use the same. There are quite a few distributed IO systems that TI Portal can communicate with. Some are legacy and some are newer. This one, what's called MP, uses the same IO modules that I had in my rack here. Now we can select to connect it to Profinet, Profibus. That's a legacy field bus. Would be this connection, but what I want to use is the modern one, which is called Profinet. And here there are various components. These are communication components, high feature, Sci+, that's with extended temperature range and so on. I'm just going to select a standard one, ST. You have a basic too. I just select one, more or less out of random. And I want to insert it into, just drag it into my project. Okay, I'm located under PLC2 because it's PLC2 that's going to have this remote. PLC1 has the IO in the same location, in the same rack. Where did that end up? PLC2, there's something called ungrouped devices. Okay, IO device 2 is here. If we click twice on it, I can change the name over here. I just call this RIO 01. What I could do if I make a system, this is IO for PLC2. So the first one, I don't have that many, but I could maybe say not 01, but 21. So it's the unit 1, IO unit 1 for PLC2. And then enter. I'm going to change the name on it. So if I double click on this one, I have a device view here too. So if I look at the properties and look at the network interface here, it has some IO addresses. We always start with this. It's a private address, and it starts with number 1. And it's not networked. I haven't networked it yet. And again, it's better to do some drag and drop. Just a little smaller. So I see if this is possible to drag up here. This should probably not work. Now I want to connect to the second one because the first one is used on this network. There was a connection. No connection. First I have to make a network. So now it was possible to and it changed the property down here to Profinet IO system. You could keep these, but maybe we should say PLC02 and dash RIO, because that's what it is. It's my remote IO or distributed IO network here. And basically this is all you have to do here. Of course we do have to save once in a while and maybe do select one and do a compilation. See what It's okay. Now all of this, when you download to the CPU, you can do that over here if the CPU is running. This configuration is downloaded to the CPU. So now it's the IO. It doesn't have any IO in it. If I double click, this is just a communication module. And it has two interface or two ports. There's one network and two ports. So when you wire it, if we go back to the network view, usually from the CPU goes into the top one here. Now we can see what kind of addresses this one get. Again, it's always properties. It's subnet. I say, didn't I change that? No. That's the Profinet. That's not. I will see if we can change that name. But it got this 1.1. I could say that, okay, my IO starts at 150. Or if we use the same system, 151. Just to have an address. Yeah, I can change the names. If we go back to network view, this is the network and the connection. I should be able to change the name on this one. What should we call? We could ask the same as the connection is PLC. Oh, it is in PLC 2, so let's say this will be RIO 01. RIO 01. I think that was correct. Yes. So that's the connection. If I go back to the network here, it's changed the name. Well, let's say we are going to insert another one and see if this name is okay. But it's just to make names on it. And if I look to, there's one thing here in also often there was no device selector, so I just don't click on this. If I look at this network here, and I'm just going to, if you scroll down here, there is on Profinet, there is a device name, and it inherits the name that I gave my unit or the communication module here. And that's okay. Of course, you can give it your own name, but just keep the names. But now, of course, it's important to have unique names, and it would not be possible to have not unique names. These are unique names. This is basically just the name for the MA or the MAC address, the medium access control address for this unit here. Easier to remember all those numbers. Okay, but then we would have to put something in here. So if I select this one, the unit says now it's changed over here, so I can insert power supply, CPUs, and digital inputs and digital outputs. So it's basically just like working with a standard CPU. Let's say there's no difference. I'm working with, here's a CPU, the other one's a communication module. So what I want to do, I just want these cards, Control X, and then I go to, there are other ways to do this too, but you can go back here and wait at the first one, Control V. So Control X is cut, Control V is paste. So what I did, hopefully I moved from PLC2 to PLC to my remote IO. So if I just go here and double click again, it's not much of IO here. So I just moved them, cut and copy. I could have just copied and pasted, but then I would have the modules here. And okay, so now I've got IO here. And the configuration for the IO and stuff is just, it's the same as where the IO is located. It's not important. So of course I could now, if I double click here, I could of course add other modules here. Say if I wanted an output, I could select something like this. So where can I place this one? They have to be contiguous over here because of this a small, what you call U element connecting these modules. They are actually the bus, the communication bus that goes through each module here. So I have to insert it here and have no spaces. You could try that and just see how it works. So the last thing I'm going to do here is this one a little smaller. I want to have another IO device on here. And again, now I'm just going to make a copy of this one. If I hold the control key down and drag, I get a plus. I have another one. And now I want to connect these to the same bus. I want to change the name for this one to, there are quite a few places you can change them. That would be RIO 2. I have used one. O. No, 2 if we are going to keep the system. And again, I can drag here, and I can probably just click outside. So I can probably drag here. I just connected. The assigned subnet of the selected device, blah blah blah. If I hit modify the next free address on the subnet. I didn't change there was a copy, but I didn't change the address. So let's go into this one and see what it changed it to. It probably, it just incremented the one. I had 151 and it was kind of smart, said okay, I have the next one. So if we now want, I could just insert, let's say, see here, I could insert more devices. Oh. Here's an overview also your units over here. The last thing you could do, and I'm going to talk about it, is the actual topology. How are these actually connected? And here you can see now you get all these connections here. So it would be drag and drop again. So this one is connected here, this connected there, and this one is connected here. And that one is connected there. And let's say what I also can do now is I can move this one back here. Then I hit it. Let's say if we move this a little down here. I said I was not going to do much about it, but this is below here. It's just to show. This is what we call hardware redundancy. This network is connected in a ring. So if you have a breakage here, your system is intact, because then it communicates down here. Can't go back. If it breaks here, it communicates down here and back. So this is hardware redundancy in communication. So that's the physical topology. And what you have to do now, of course, is to do the same connection. The lower one here to the top one here, the lower one there to the top one here, and the lower one here back to the top one up here. I could do the same. I could make an IO system also for my other PLC, the PLC01. It's usually, again, you can place them within here, those are space, but doesn't look too bad. Usually you would move this one down one level, as I did this is just for the display. I say my IO is still on a lower level. So this is level 1, or level 1, 2, and 3. And we have the HMI system up here. Okay, it's graphical. Well, that one disappear. No, that's only one. It's mostly it's important for IO and stuff here, also like that. Let's see. Now back to network view. Yes, I think this is basically, if we try to compile again, that was the 2 where we did on both of them. See if that's, I've done something wrong. Yes, I did. Oh yeah. As PLC2, I have to do some special for a ring network and stuff. It has to be special. So maybe I should go back, see if it compiles. Which one there was? Yes, top one. I'm just going to delete this one and check. No, it would compile. There are some additional steps that has to be. I didn't do those because you have to say that this is a ring configuration. So now I just deleted it and say I have no ring connection. That's just to get an error-free compilation, or I would have to take additional steps. Yes. So just to recap here, what's been done here is first I had a PLC in my project. The first thing I did was I inserted an HMI panel and connected first the network, and then I had to make something called a connection. What kind of language are you going to use? You are going to use the HMI PLC language to talk to each other. And for these systems, they are built in. In firmware, the communication software is in the firmware, so they can talk to each other. The next thing was to duplicate my CPU. What I did, I had to change a little on the IP addresses and so on, and then I connected those first networked to the same network as the HMI panel. That's what I decided to do. Didn't have to do that. And then again, they also need, there are quite a ways they can talk to each other, so to speak. And what I select was something called an S7 connection. That's special for communication within or between PLCs, also with HMI panels or other systems in the SIMATIC world. And again, I've first the network connection and then a type of communication. And between CPUs, they can't talk to each other. They need function blocks or programs to talk to each other. And I showed one put. There was one that just collects data in one CPU and puts it down in another CPU via the connection that is configured. So a program, and then that has to be configured to the function block. I need to put some information into it so it knows that it's PLC2 I'm going to talk to. It's a little more involved. It's not going to be covered here. And the last thing was this remote IO. Remote IO is the IO is located somewhere else. And the reason why it's located somewhere else, it's not space in the cabinet where the CPU is, too many cables, and too much IO, whatever. But I can't have the IO next to my CPU. The last thing I did was I make a copy of that, make the ring configuration, connected this in a ring, and it wouldn't compile. Because then I have to do a little more. I have to say, this is a ring configuration. How is this going to work? So I just delete it again just to make it compile. And what you do is compile and save once in a while too. I forgot to save. Now I did. And compile. Because then you get what's correct. And usually when it compiles error-free, it usually works when you download it. So this was a quick introduction to networks and communication within the SIMATIC PLC world.